Good morning, everybody. Welcome to day 7 of Advent of Code. Today we'll be solving something regarding CLI, as we can see the classic CLI commands here. So let's see what have the organizers prepared for us today. So the device, the communication system, has problems with space. It doesn't have enough hard drive space on the device, so we'll be helping them fix it. So the input will be a kind of output from CLI. The main directory is called /, and we navigate around the file system, moving in and out of directories and listing contents. So each command starts with $, and then we have commands of cd, which goes to another directory, or up, or to the root directory. And ls means list. It prints out all the files and directories. So basically, based on the output that we see, we are going to reconstruct the directory structure, the directory tree on the device. Our goal is to find total size of each directory, and then some total sizes of directories with at most 100,000 size. Okay, let's get started just with the basic implementation of the directory tree. Just to command it. So in this case, we'll need some helper classes. So I will create a class for directory, and it's gonna be have properties name, property of list directory, directories, and it's gonna have a list of files. Yeah, file. I'll create class for file. I'm not sure if we will need the name, but just to make sure that we cover all the potential things, I will create a name property as well. And I will create a method or it's gonna be proper. Let's make it a property which will return the total size of the directory. So and for each. This way. So it's gonna be a recursive solution where we sum up the size of all the files that are directly in the directory and then all the sizes of subdirectories of the directory. And as a result, we then return size. Okay. So that's it. And now we... now let's implement the reading of the input. So oh, right. Just created a clash against... oh, whatever. I will just be explicit here. System IO file. So now we will go through all the lines in the CLI output. All right, what we need also is to have a link to the parent. So that we can go up up a directory. So for starters, the root directory will be null. As the first command should be /dir. Let's see if that's true here as well in the advanced code. Yeah. So the first command is cd / which will go to the / root directory. We'll create that one. Okay, let's create a constructor here. Let's not make it optional, let's make it explicit so that we don't forget to set the parent on other directories. Okay, so I will create the root directory. And now it's nullable. And now I will create a variable that will hold the current directory. I will set it to root directory directly. And now let's read the input. So, oh, okay. So first we'll need to identify if the line is a command. So if it's a cd command, right, if. So we split it, split line by spaces. Actually, we can split the line always because we will need it for all the cases. On all the lines is a space, so line split. So line split. So the this will be the command. Okay, let's do switch. essentially there is just one command really care about, that's cd, because ls will just read the files to the current directory automatically. So we really care about just cd. So linus cd, and it's not gonna be this, but one. Then if it's a cd command, so if linus if it's transition to the root directory, we'll set the current directory to root. Else, if it's go up command, will go current directory parent. And finally, else other cases will go to the current directory with, this, with the given name, or we make this nullable. But in this case, we know that it's not gonna be null, so I will use some exclamation marks so it's marked as safe. So now if we are going to another directory, so target name linus 2, so if any directory has a name, if not now no, if this directory is not yet known, we will create it. So current directory name, name, we'll create it and add it into the list of directories and set it as the current one. And we'll set it as the current one anyways, so if it doesn't exist, we will create it, and in all cases we'll go into that directory. So current target. Okay, and now all the other cases are reading files and contents of the directory. So the contents are like this. So there is either dir for directory, subdirectory, or there is this for number, the size of a file. So if line split 0 is dir subdirectory, so we'll create a new directory. Oh, actually, let's always, to make sure that we don't make any mistake. Oh, let's make a method here. Like bool. and public pool. Okay, so now we will check if if current directory, this directory, so if it's not already there, we'll create it. Oh, basically the same thing as we did here. Right, so this is the thing we need. So this is for subdirectories, and else it's file. So if not current directory contains file, then we will create it. Right, very similar to this, although we don't have any constructor yet, so I'll create it. So it's gonna be string name long size. And long parse line split 0. So this will give us the file, and we just add it to the list of files here, and we are done. Okay, so now after reading all this, we can find the directories with less than 10,000, 100,000 size. So small dirs. Oh, now the proper way would be to sum it up from the bottom, but because the input is not that big, I think we can just do it in an inefficient way here. So I'll go, oh, or yeah. Actually, we can. What we can do. After each, right, when ls is finished, we can take the size of the directory, because that means that we read it completely, or we did not, because we can go into that directory later again. So right, well, what we can do is, instead of calculating this whole thing recursively again and again all the time, we can store it, because when we first get the total size, it's because we already finished reading the whole document. So what we're gonna do is total size. We'll cache the value once we read it. So let's cache it. It's gonna be, let's make it nullable. So if total size is not null, if it's not null, we will return it directly. So this way when we trigger the search, or the total size for root directory, it will calculate all of the other directories, and then we will just be getting the cached value from all of them, so it's gonna be much more efficient. So let's what we need to do is to traverse the whole tree. So we'll start with, we'll set the current directory to root, and we will small directories will be a list of directory. Now we'll traverse. So we'll what we're gonna do is that we will have a stack. Or let's make it just recursive. So I will make a method. Now traverse directories. Okay, so we'll first check if the source has lower size than we require. So if source is it at most 100,000? At most, okay. So it's less than or equal, and we add it. Right. It's complaining, but we can pass it in. So like this. And let's do traverse directories from root to the bottom. And then we will take the subdirectories as well. So like this. So when we are done with all this, the list small directories contains all the directories with lower size than 100,000. So now we'll do console write line, small directories, sum total size. So this should be all we need. Okay, it took quite a while to write this, but hopefully this is the complete solution. I will just test it on the simple input again as always, just to make sure that I didn't miss anything. Okay. So what do we get? Ah, 95,437, which is, yes, that's correct. So it seems promising. Let's plug in the full input. And let's run it. Okay, fingers crossed. That's correct. Okay, so we have the first part solved. Now for the second one. So we need space of 30 million. Okay, we need to find the smallest directory that will free up enough space. So what we need is okay, so we'll create a new project for this. Today 7.2. Let's copy the whole thing. So we need a total disk size of 70 million. Required disk size is 30 million. And so when we finished reading through the whole content, we will have the root directory size. So root directory total size. So we now know what we are using, and our goal is to decrease that as needed. So wait, so we have right, so we need to clean up the difference. So right, nice, which will be total disk size decreased by used size, and what we need is required disk size minus used size. Oh, okay, unused size. So now what we need is to find the smallest directory, which is at least this big. So we'll initialize it by root directory, and then we traverse. Total size. We'll output that when we're done. And when we're traversing, we will do if the current directory size is smaller than the best directory, and it's also bigger than what we need, so like this. If disk directory can satisfy the condition and is also smaller than the best current one, we will update the best. So this way, and then we'll traverse recursively to the others. Okay, so that should be it, hopefully. Let's first run it for sanity check against the simple input. Okay, 4 A3. No, that's far too big. So this is the root directory, but we should be able to use the directory D there. So what went wrong there? Oh, right, I mixed up the condition. So the source needs to be smaller than total size of the best one. We're finding the lowest that satisfies the condition. And that's not correct, right? Oh, that's also wrong. Okay, let's see. Ah, that's weird. So the root directory has a size of... Let's put a breakpoint here. Something is fishy going on there. So unused size is... Used size is this. That seems okay. Unused size is this. Yeah, 838. Okay, that's right. Okay. What is wrong here? We have the root directory, which is big enough. Then we have directory A, E, D. And now this one should pass the check, but it doesn't. Why? $8 million, and this is 24 million. Right, I'm stupid. I mixed up the condition again here as well. Both are wrong. All right. That was a low moment. Okay. Oh, I run. Let's run. Okay. This is now fine. So this is the correct one. Okay, so let's plug in the full input. Run it. And this is our solution, hopefully. Okay, that's it. All right, so it took a bit of time, but we have the solution to day 7. Okay, so far so good. Okay, thank you for joining me for day 7. Make sure to subscribe to see notifications about the next days, and I will see you in the next video. Have a great day.